So what is the radian? Well, the radian is just a unit of angle. We already know about the degree. We know that that's a unit of angle, and we use that all the time. Well, a degree is a tiny little sliver. If I draw a degree on here, then it's only about probably that big or smaller, because we know that there are 360 degrees around a complete circle. There's 1 degree there. Well, a radian is just an alternative unit, really, but it's got a kind of curious definition. 1 radian is the angle at the centre of a circle subtended by an arc length equal to the radius of the circle. So what does that mean? Well, arc length is just the distance around the circle, around the circumference. We know that if I go all the way round, well, that arc length is equal to the circumference and is equal to 2 pi r. So total arc length, let's write that down, is the circumference, which is 2 pi r. That's useful a bit later on. But we just want a smaller arc length than that. We want an arc length just equal to the radius of the circle. So let's draw the radius back on, there it is, and label that r. And so let's just start from where that radius is and just go a distance r. Well, that's probably to about there. And if I join it up the other side, and if we say that that's a length r, well, the angle subtended by that arc length just means the angle made by that triangle, or not triangle, those 2 radiuses, or radii. So the angle in there we call 1 radian. So that's what a radian is. And we can see that it's actually quite a big angle, quite a surprisingly big angle, really. So let's look a bit deeper. Let's look what's going on. So let's draw our definition of the radian again. So we know that it's the angle subtended by an arc length equal to 1 radius. Well, approximately speaking, I would say that that's about 1 radian, the angle in there, 1 radian, as we've already discussed. And we can quickly see, well, okay, we could look at an angle of 2 radians. Let's see what that looks like. Well, it's going to be twice as big. So it's probably going to be something, what, about that big, do you think? Maybe something like that. And so that angle of 2 radians in there, well, that must be the angle subtended by an arc length of 2r. Kind of makes fairly obviously. So that distance around there would be 2 radiuses, equal to 2 radiuses, and the angle in the gap is 2 radians. How you write the unit radian is rad, so 2 rad means 2 radians. We can generalise that. You know, we could look at, instead of an arc length of 2r, we could look at an arc length of xr and an angle of x radians. So let's suppose we had an angle, I don't know, somewhere over here. Let's have a really big angle, which is some unknown amount of radians, x radians. And that's the angle all the way around here. Zoom. Well, that must be the angle subtended by xr, an arc length of xr. Let's try and draw that on. Well, that would be the arc length going all the way around from side to side there. So that's an arc length of xr. So the arc length is always the radius times the angle, in other words. And so finally, let's just look at what happens if we go all the way around the circle. Well, we already know that size of that arc length, because as we talked about in the last page, the arc length all the way around the circle is the circumference. Yeah, in other words, the distance going all the way around is 2 pi r. We all know that. That's what we call the circumference of a circle. But that means that the angle in there, well, what would it be? Well, it must be 2 pi, because whenever we multiply the angle by r, we always get the arc length. X times r gave us xr, 2 times r gave us 2r, 1 times r gave us r. So that's the beauty of the radian. We can see that the complete angle around a circle is equal to 2 pi radians. So that's kind of useful information because we kind of gives us a conversion. We know that all the way around a circle is 360 degrees. And so we know that that's equal to 2 pi radians. I should label that really radians there, 2 pi radians. And we can then figure out a bunch of other kind of easy angles, like 180 degrees, therefore, would be pi radians. What is 2 pi? I mean, 2 times pi, if you put that in your calculator, well, it's approximately 6.28, 2 times 3.14 radians. So, but it's more exact to keep it as written as 2 pi, which is why people tend to write it like that. So yeah, 180 would therefore be pi radians, and 90 degrees would therefore be pi by 2 radians, and 45 degrees would therefore be pi by 4 radians. So a few nice easy angles that we know straight away in radians what they would be. What if we had a kind of funny angle, you know, like 63.5 degrees or 12 radians or 1.6 radians or 50 degrees or whatever it is that doesn't just fit into one of these kind of easy ones? Well, we need some way to kind of convert. So let's have a closer look at how to convert from degrees to radians and radians to degrees. We'll start off by just remembering that 360 degrees is 2 pi radians. So let's see how to convert from radians to degrees first of all. And we'll start off again by just writing that fact down. So we know that 2 pi radians is 360 degrees. Well, we can pretty quick find out, therefore, what 1 radian would be, because 1 radian, therefore, would be 360 degrees divided by 2 pi. So it would be 360 over 2 pi degrees. And then we can pretty much find any value, you know, for example, well, 2 radians then would be 2 times that factor. Let's just simplify that factor first. If we have a closer look at that, we could actually cancel that fraction down a bit, couldn't we? We could say, well, that's actually 180 over pi degrees. And we could even write it as a decimal. You know, if you punch that in your calculator, 180 divided by pi, it's to 3 significant figures, it's 57.3 degrees. Like we said, it's a big angle, 1 radian, remember, it's nearly 60 degrees, a huge angle. So 1 radian is 180 degrees over pi. So that means 2 radians would simply be 180 over pi times 2 degrees. And of course we can just generalise that now. So let's just generalise that for x radians. So if we want to find out how many degrees x radians is, well, all we have to do is do 180 divided by pi, because that's 1 radian, and times it by x. And so that's quite a nice, easy way to convert from radians to degrees. So let's put a kind of bubble around that. Nice formula to remember, or to use, or to be able to figure out when you need to. Quick example, let's just do a quick example. So we might say, okay, express 2.5 radians in degrees. Well, we just chuck it in the formula. So we say, well, that's going to be equal to 180 divided by pi times 2.5. And if you chuck all that in, well, it gives you 143 degrees. So we can successfully convert any angle in radians into degrees. Okay, good. So let's look going the other way. Well, if we want to convert from degrees to radians, then, well, we start pretty much from the same point, but the other way around. Well, 360 degrees is 2 pi radians, which means that 1 degree is 2 pi divided by 360 radians. And again, we can kind of cancel down a little bit there. We could divide the top and the bottom by 2. So we actually get that 1 degree is pi divided by 180 radians. So that's our kind of conversion factor this time. And then we can find any number of degrees we like by just multiplying by that. So for example, 3 degrees, what would that be in radians? Well, it'll just be 3 times pi over 180 radians. And if we put that in our calculator, we get to 3 significant figures, 0.0524 radians. Tiny angle in radians, of course, because 3 degrees is a tiny angle, and a radian is a big unit, so we're going to get a very, very small, much, much less than 1 radian, which makes sense. And so then we can just figure out now a conversion equation by saying, well, we know the conversion factor is pi over 180, so x degrees is going to be pi over 180 x radians. And so we've got another useful formula to convert the other way. And let's just do a quick example for that one. So express 35 degrees in radians. So, well, we just chuck it in and see what happens. So, well, we're going to say that is equal to pi times 35 divided by 180. Well, if you put that in your calculator, your calculator will probably come up with 7 pi over 36, because it likes to keep it in an exact form. And that's fine. We could write down that 35 degrees is 7 pi over 36 radians, but more likely as physicists we'll put that to 3 significant figures. So it'll be point, and if you press the conversion button on your calculator, the SD button, then it gives you 0.611 radians. So there we go, we've done a conversion, we found 35 degrees in radians, we can convert both ways. So, well, that's the radian, that's how to convert, that's what it is. Have a go at the challenge, and then we'll move on to use radians, looking at motion in a circle.